March the 6th, 2021. As you're looking at the USGS earthquake map, it's the top link on the left side of our website at bpearthwatch.com. There's been a lot of pressure down north of New Zealand around the Kermadec Island region for the last several days, and it hasn't let up. Usually when you start having 8.1 quakes and 7.4 and 7.3 quakes, that pressure will relieve, but there's still, the pressure is still there, in other words, and it's a lot of pressure, and it is at a major break point that over millions of years has kind of been like a fuse. As the pressure builds up on the ring of fire, you'll have certain areas that you see the large quakes in, and if you look at the geology of the area, and I'll zoom this up, you can see that there's been so much pressure there that it's bent that actual entire area. But if it wasn't for those areas, then you would have a lot more powerful quakes in many places. Now, I've got this set for 7 days, all magnitudes, and for the U.S. Now, it picks up all of the larger quakes around the planet, too, most of the time. But here is where we started out. Look at the right, on the left side here. We were getting like 1 to 3 foot tsunami warnings and watches there. But and as you just saw on the bottom of the screen, I've got my updates turned on, so that's been popping about 1 a minute, and that's just new quakes coming in. But the 8.1 started it, then you had the 7.4 and 7.3s. Guys, these are incredibly strong earthquakes. So we're dealing with, of course, we're going into spring equinox time, and you've got different planets in different places, different gravitational forces, and the tilt of our planet is actually will be moving towards summer. But we've got extremely high solar wind buffeting the planet right now, and that's got a lot to do with this. And not only that, if you'll start going, and again, the links are all on bpearthwatch.com, but go there and start looking at your earthquakes, your solar winds, and your volcanic activities. There's another quake that was just updated. You'll notice that Mount Etna and Cinnabon, some of the mountains, volcanic mountains around the planet, are going off because that energy is being fed into the magnetic field lines of our planet that go through the core. And all of that energy is being absorbed, and that's what we're seeing happen now. And you'd think that would be more energy during the summer, and there is quite a bit of that, but our shields are weak, and we're going into grand solar minimum. The weaker the shields, the more this energy is transferred into the ground, the more of it is allowed to be transferred. In other words, strong shields, strong plasma fields there in your plasmasphere that block a lot of this. But when the sun is weak, that energy that actually creates this planet, this gyro that we're spinning on and keeps it spinning, is solar wind. But when it gets high, then it shifts and changes, and it affects the planet. But I'm going to change this map slightly. What you're looking at is 2,073 quakes are showing here. There's actually a little few more, but I haven't got all of that in. But let's just pull up to the New Zealand and up off the coast of Auckland into this region. I'll point out a couple things. This is your 8.1, and look at the magnitude of the aftershocks right here off the Kermadec Islands. It goes on. And these 5.9s are strong quakes. It was a 5.3 or 5.4, I think, that cracked the Washington Monument with people in it a few years ago. You guys remember that? So when you're going magnitudes higher in strength, there's another quake just came in. We've got, again, the Earth slightly tilting, going through those changes, buffeting of solar wind speed. And I've always thought that when certain planets line up a certain way, it increases that gravitational pull on all the planets, and that's been talked about before. But space weather is Earth's weather, and it becomes Earth's earthquakes and volcanoes. and things like that. But we're now looking in this area, tremendous amount of quakes still coming in, and they've been going on like that. But what I want to do now is take an actual look at our magnetopause and the solar wind. You'll see what's happening. Now, before we look at the solar wind speed, I want to show you this particular formula, and it's simply converting kilometers per second, in this case 600, because the satellites are picking up the peaks at 600 kms per second, or kilometers per second. That's 1,342,162 miles per hour. You don't think that can put some pressure on something? It very well does, and we've seen it year after year. And it's worse during the grand solar minimums. And just as a side note, a lot of the Malter minimums, the extremely cold times in our history that have frozen parts of the planet and people have had to migrate, they had a lot of volcanic activity, which added to the problem of ash covering the sun, or preventing the sun from hitting the ground. So it just gets colder, less sunlight, the whole 9 yards. It adds up and piles on. But this is the type of solar wind speed that we're dealing with now. Let's take a look at it. Guys, what you're looking at now is coming in from the Discover satellite system, and it's an early warning system for our planet. And sometimes 45 minutes it'll strike these satellites before it hits the Earth's shields, just depending on how fast it's actually moving. Three lines that we're looking at is the density in centimeters cubed. That's how much plasma energized particles are in the wave. That's how thick it is. And the purple line is your speed, and this is a 3-day chart. We're going back. Then here we're going into yesterday, Friday. We start to see this bump and rise, and the earthquakes pick back up. But again, 550 getting here. And they were, if you dial it into 1 day, you can start to get very close to 600 right here today, 590, and that's kind of peaking off the chart, 580 right in there. And again, on the daily charts are showing 4 bumps that I know of at 600 kilometers a second, again 1.3 million miles an hour. Here's your temperature, and it will usually move in lockstep with the wind speed. In other words, the faster the energized particles are moving through space, and then 93 million miles later hit our planet, the temperature rises with that of that solar wind speed, and you can see it correlates. The density, guys, which this is kind of a different chart than they normally have. It's calibrated to go all the way up to 100. You see some of the peaks a couple of days ago getting up to 42.5 centimeters cubed. That's very dense, and normally you won't see that unless it's a very powerful coronal mass ejection. But again, our shields are weak, and we're dealing with this. But it normally will go down as the solar wind speed goes up, and you can see how that correlates here. As the solar wind's peaking, both in speed and temperature, the density goes down. Why? Because if you have so many particles in a cloud, the cloud's just drifting, it's very dense, but if there's a high wind pushing it, it's going to spread that cloud out, thin out the density of the particles, and that's what you're seeing, this thinning out process. But guys, we're watching it. You watch it. We're starting to see in those quakes, getting some strong 5s up around Kamchatka, Russia. They're moving over to Alaska. You can go, again, to bpearthwatch.com and look at the link on the USGS top link on the left. It's a good time if you're in a fault zone area to pay attention to this, because I've said this for the last couple of years, that we are going into a kind of a new science with this solar minimum, because we're going into grand solar minimum, which we're experiencing the effects of, and we have the satellite and computer technology to actually see this and witness it and able to calibrate it and look at what's happening. We didn't have this years ago. You know, we had some satellites and some ground-based information, but now it's getting to where, with the technology we have, that more and more people will I hope, will begin to understand the effect that the sun has on our tectonic plates. We're watching it, guys. You watch it. It's a heads up. Be safe.